My name is Alejandro Dick and I am going to talk about Arduino radar. Overview. The purpose of this project is to show how to design a simple Arduino radar application using Arduino and a processing application. Definition. Radar is a long-range object detection system that uses radio waves to establish certain parameters of an object like range, speed, position. Radar technology is used in aircraft, missiles, marine, weather predictions, and automobiles. The project is based on a sonar technology and an ultrasonic sensor to determine the presence of any object in a particular range.
Hello. This video is brought to you by Grook Network. For source code and schematic drawings, please visit the link below in the description. How to make an ultrasonic radar using Arduino Uno and processing application. Now, the radar is rotating 90 degrees and calculating the distance away from the ultrasonic sensor. It is sending the data, angle, and distance to the computer using serial port. Processing application is converting the polar to rectangular coordinates and showing them on screen. This is the diagram of the network. It is simple. You can download it. Parts list of the project. First, and the most important component is the microcontroller. In this project, we have used Arduino Uno. For more information, please visit Arduino CC. Second component is the ranging module HCSR04, which provides 2 to 400 cm non-contact measurement function. The ranging accuracy can reach to 3 mm. The module includes ultrasonic transmitters, receiver, and control circuit. The basic principle of work is by using input-output trigger for at least 10 microseconds high-level signal. Then the module automatically sends 840 kHz and detect whether there is a pulse signal back. If the signal back, through high level, time of high output input-output duration is the time from sending ultrasonic to returning. The third component is servo. You can use any suitable servo. In this project, we have used Tower Pro Micro Servo 9G. It can rotate from 0 to 180. In this project, we have used from 45 to 135 degrees. We used some balsa wood for making the base. We tried to keep it very simple. And of course, wires and breadboard. Please note that this is a simple project for educational purposes. If you want the source code of the Arduino or the processing, please visit the link below. Please feel free to edit and improve the codes. It will be nice if you keep a link of brook.net. Email us the new source code for sharing it on our website. Thank you for watching. We hope that it was informative.
Utilities. Radar use signals that bounce off the surface of the bodies and return to determine the distance of objects. The radar travels from 800 to 1600 degrees to detect what is around and even to determine the speed of the bodies moving towards the radar.
Radar is a method of detecting distant objects and determining their position, velocity, or other characteristics by analysis of very high-frequency radio waves reflected from their surfaces. The word radar stands for radio detection and ranging. Several inventors, scientists, and engineers contributed to the development of radar. The first to use radio waves to detect the presence of distant metallic objects was Christian Holzmann. Whether it's mounted on a plane, a ship, or anything else, radar set needs the same basic set of components: something to generate radio waves, something to send them out into space, something to receive them, and some means of displaying information so the radar operator can quickly understand it. The radar waves are generated by a piece of equipment called a magnetron. Radio waves are similar to light. They are made up of fluctuating patterns of electrical and magnetic energy, just like the light waves, and they travel at the same speed. But the waves have much longer wavelengths and higher frequencies. Once the radio waves have been generated, an antenna working as a transmitter hurls them into space. The antenna is usually curved so it focuses the waves into a precise, narrow beam, but radar antennas also typically rotate so that they can detect movements over a large area. The radio waves travel outward from the antenna at the speed of light and keep going until they hit something. Then some of them bounce back towards the antenna in a beam of reflected radio waves, also traveling at the speed of light. Any reflected radio waves picked up by the antenna are directed into a piece of computerized electronic equipment that processes and displays them in a meaningful form on a television-like screen, watched all the time by a human operator. The receiving equipment filters out useless reflection from the ground, buildings, and so on, displaying only significant reflections on the screen itself. Using radar, an operator can see any nearby ships or planes, where they are, how quickly they are traveling, and where they are heading. There's one more important piece of equipment in the radar apparatus. It's called a duplexer, and it makes the antenna swap back and forth between being a transmitter and a receiver. Radar is something that is in use all around us, although it is normally invisible. Air traffic control uses radar to track planes both on the ground and in the air, and also to guide planes in for smooth landings. Police use radar to detect the speed of passing motorists. NASA uses radar to map the Earth and other planets, to track satellites and space debris, and to help with things like docking and maneuvering. The military uses it to detect the enemy and to guide weapons. Meteorologists use radar to track storms, hurricanes, and tornadoes.
Steps: list of materials: arduino, servo motor, jumper cables, ultrasonic sensor, masking tape, plastic strips. We built a simple radar using an ultrasonic sensor, a servo motor, and a processing app to graph the information. We connect the Arduino to the app with the serial ports. One of the conclusion. One of the sensors most used for its ease of use is the distance sensor, such as the ACSR04. By means of ultrasound, it measures the rebound, and we can easily know the distance of an object. It is especially useful in robotics, but if you want to take your project to the next level, you can join it with a processing app and build a simple radar.